Hello. In this video, I'm going to guide us through an overview of the first unit for quadratics. So this will act as a review, and it'll also act as our guided review sheet. So if you follow along and make the review sheet as I've shown right here, you can use this on your test. So it acts as a review today, and it also kind of acts as a cheat sheet that you can use on the test so that you have some examples to go off of. There are, I think, 5 sections that I'm going to cover, and then the last one will be for any extra examples you'd like to put on your review sheet. So I would recommend making 3 sections on the front and back of your paper. That way you'll be able to have it organized. So 3 sections on front, 3 on back. If you need to pause, go ahead and do so. Otherwise, I'm assuming that we are good to go, so I'm going to start. The very first section was 7.1. It was on adding and subtracting polynomials. We're specifically going to look at a type of polynomial called a quadratic, where the highest power is going to be a 2. The highest power we call a degree. So the first thing that we did in this unit is we looked at how do all of the operations that we learned about in elementary school, adding, subtracting, multiplying, and dividing work with quadratics. So in middle school or in elementary school, you learn how to add, subtract, and multiply and divide numbers. In middle school, you focus on adding, subtracting, multiplying, dividing with some fractions. And then in high school, you look at how do you add, subtract, multiply, and divide. We call it factoring polynomials. So title that first section 7.1, adding and subtracting polynomials. If you need a little overview of what that is, here's a little picture I took from one that the book did. I would put these two examples though down on your review sheet. This top one's just to refresh your memory. I'm going to guide us through this first one, and then I'll have you try the second one on your own. So I'm going to zoom in on the second one, make it a little easier to see. So I want to add these two quadratic terms or expressions. Each expression is in parentheses, and the way that I taught it is let's line it up like we did. Let's zoom this in even a little bit more. There we go. Let's line these things up like you did and even in elementary school. So I have my x squared columns, my highest power, then my x's, then my ones, my constants. This is x to the second power, this is x to the first, this is really your x to the zeros, your constant terms, your number ones. So 5x squared, there are no x's, so we have a placeholder of 0 x's, minus 7 over here, this is a negative. So I have a negative 1x squared plus 4x plus 8. I line up my terms, and then I'm just adding term by term. That's why in elementary school they said it was very important to line up your decimal places, because then you'd be adding like terms. Then you just go adding. 5x squared plus negative 1x squared is 4x squared. 0 plus 4x's is 4x. Negative 7 plus 8 is 1. You cannot combine these. These are not like terms, so you have 4x squared plus 4x plus 1. And that would be the answer for the first one. Second one is a subtraction question. I'm going to give you a chance to try it. So pause the video now, and then unpause it once everyone's had a chance to try and you'd like to see what the answer is. Same strategy, line up your place values. So you have n squared, n, and then your number terms. If you would like, you can change this to be an addition question by making it plus, and then it'll change the sign of everything in the second one, so it'd be a negative 8n squared plus 4n and negative 17. If you don't want to do that, that's fine too, but I just wanted to show it in case some people really struggle with the subtraction, so you can always make it addition by changing the sign of the second. Subtracting is the same as adding the opposite. So if you'd like to leave it a subtraction, you can do that. Final answer, 3 minus 8 is negative 5. Negative 4 minus a negative 4, that's negative 4 plus 4. 0 ends. 1 minus 17 is negative 16. So we'd say negative 5n squared minus 16. And that is how the first section went about. After adding and subtracting, we then looked at multiplying. So the title of that second box on your review sheet should be Multiplying Polynomials. So title at 7.2, Multiply Polynomials. And then I'm going to show one example, then I have 2 down here for you to try. So maybe just watch me do this first one as an overview. There were 2 ways I presented this. You can either use a table to kind of show it, so it's a multiplication table method, or you can use multiple distribution. The book called this foiling. You're not going to hear me call it that, because foiling is only a specific case. Thinking about it as multiple distribution is a much better mathematical concept. So if I were going to do it by using the table method, I'd have 5y and then a plus 6. It doesn't matter if you place it along the height or the width, it's going to be the same. y minus 3, then I just go multiplying. 5y times y is 5y squared. 5y times negative 3 is minus 15y. 6 times y is 6y. 6 times negative 3 is negative 18. Then combine your like terms. I have 5y squared. 6y's minus 15y's is negative 9y's, and then negative 18. And I can't combine those. Those aren't like terms. There would be the final answer of multiplying those. If instead you did multiple distribution, here's what that would look like. It's this, you should get the same answer, just a different strategy. 5y times y is 5y squared. 5y times negative 3 minus 15y. Now this 5y is done distributing. The next item in the expression goes 6 distributes. 6 times y is 6y. 6 times negative 3 is negative 18. Combine your like terms. 5y squared. Negative 15y plus 6y is still minus 9y. Minus 18, and voila, you notice you get the same answer. It's just two different techniques. I don't care which technique you use, I'm just presenting both because it's usually about a 50-50 split for preference. Use those as your guide. I'd like you to try these two problems. So pause the video now to give people a chance to try. Once you've had a chance to try, you want to see the answer, unpause the video. Okay, welcome back. Here's the first one. I did the first one using a table. I think I do the second one doing distribution. I do just to show x plus 6, x plus 2, you multiply, you get x squared plus 8x plus 12. You'll notice the 12 is the multiplication of 6 and 2. It's 6 times 2. 8 is the addition, 6 plus 2. That's going to be your key to factoring in the next section. Then when you multiply this one, I did multiple distribution. When you distribute, you get 2x squared plus 8x minus 1x minus 4. Combine the like terms in the middle. You get 2x squared plus 7x minus 4. And that is it for the second section. So that's what have we done so far. We've done adding, subtracting, multiplying. The next section is on special multiplications before we actually jump into division. So we have special multiplications and then the very beginning of division, which we call the greatest common factor factoring. So 7.3 kind of has two titles. It's special products and factoring out the greatest common factor. You'll see this abbreviated GCF, greatest common factor. So this was the end of multiplication and the very beginning of division is what it was. So 7.3, special multiplications and factoring out the greatest common factor. This first example that I'm going to just talk about real quick is the special case for multiplication. X plus 4 squared is not simply x squared plus 16. That power does not distribute. It doesn't work like that. To square means to multiply something by itself. You have to do x plus 4 times x plus 4. You're going to see you get a different answer than if you did the top part. When you distribute, if I do x times x, I'm going to get x squared. X times 4, I get 4x. Then I distribute the 4, I get another 4x. And then 4 times 4 is 16. So I do get an x squared and I do get a 16, but if you try to take this shortcut, you're going to miss the 8x's in the middle. So the final answer is x squared plus 8x plus 16. That is the correct answer. It is not simply just x squared plus 16. Don't go trying that. Then the very beginning of division over here was greatest common factor factoring. It's essentially the backwards of distribution. Like if I gave you this problem down here and said distribute, you would distribute this through and you'd get 6x squared plus 42x. But now it's the opposite. Imagine I give you the answer and ask you to work backwards. How would you do it? Well, the first thing you would ask is what's the biggest item I can divide out of 6 and 42, the biggest number? Well, it's a 6. And then I go looking at the variables. What's the most amount of x's I can divide out of both? This has 2, this has 1, this only has 1. So what's divided out? A 6 and an x is the most I can divide out. What has to be left behind? Well, there needs to be an x here because 6x times x would make 6x squared. There has to be a 7 because 6 times 7 makes 42. There can't be any more x's because there's only one x here, and once this 6x distributes, it'll be 42x. So this must have been the way it was written before it was distributed. So that's what we'd call in factored form. Sometimes you even see parentheses written around that. So there's two examples to go off of. On your piece of paper, I'd like you to try these two. So pause the video now, try these two, try a special multiplication, and try solving by doing the greatest common factor factoring. So you need to divide the greatest common factor out and then actually solve it. So pause the video now, unpause it once you've had a chance to try. Okay, welcome back. First one, you can't just distribute this and say it's x squared plus 11 squared. No, you need to multiply it out. you're going to end up getting x squared plus 11x, and 11x makes 22x's, and then 11 squared, which is 121. So you have to multiply it out. Second one, biggest number I can divide out of 4 and negative 8 is a 4. The most amount of x's I can divide out of x squared, and an x is an x. What is left behind? An x and a minus 2. Now it's factored and I can solve. What would I have to multiply 4 by to get 0? Well, 0. What would I have to have x be? So it's x minus 2 equals 0. X would have to be a positive 2. So 0 and 2 are your two solutions to this equation. And how did we solve it? We did it by factoring. So that's the very end of multiplication, very beginning of division. In the next section, we did full-on factoring, and then we used it to actually solve some equations. So 7.4 and 7.5, it was a combination of two sections, was on factoring and solving by factoring. So it was solve equations by factoring. So I'm going to work an example, and then I'll have you just do a factoring one, and then you solving an equation by using factoring, because that's the biggest benefit of factoring, is allows us to eventually solve equations with powers of 2. So there's the title of the section here. I'm going to work one. Let's go back to multiplying so you can see the pattern here. Look at this one, x plus 6 and x plus 2. I mentioned this a bit ago. 12 is the multiplication of 2 and 6. 8 is the addition of 2 and 6. So if I knew this was the final answer, I can work backwards and know what these numbers would be, because 6 and 2 are the only numbers that multiply to be positive 12 and add up to be positive 8. That's going to be how I think about this one. I need to find the two numbers, because I know that this is going to factor. To be something like this, that multiply to be negative 63 and add up to be 2. If they multiply to be negatives, one has to be positive and one has to be negative. If they add up to be a positive 2, I know the biggest of the two numbers needs to be the positive. So now I go listing all the ways I can multiply to get 63. And there's not too many of them. If the biggest one's positive, 63 and negative 1, but it can't be that, because that adds up to be 62. 2 doesn't go into 63, but 3 does. I think it's 21. So this would be 21 and negative 3, but that's not going to work. Those would add up to be 18. The last combination, I believe, is 9 and negative 7, and those ones work because 9 plus negative 7 is 2. So it's got to be x plus 9, x minus 7. That is if it just asks you to factor, you are done. So how can you check? You can multiply. X minus 7, x plus 9. I'm doing a table to check. You can also just do double distribution over here, and it would work out as well. And I look. 9 plus negative 7 makes positive 2x. 9 times negative 7 makes negative 63, and you'd be done. So if it just asks you to factor, you're done. If this equation was equal to 0, though, you have one more step, because you have to solve it. So if it's equal to 0 and it says solve, you have to actually tell me what x would have to equal, because the first part was just the factors. The second is if it equals 0, you need to tell me what x would have to equal. X would have to equal a negative 9 in order for the first thing to be 0, or x would have to be a positive 7. If I have two items multiplying to make 0, one of them has to be 0. What would make the red thing be 0? If x equaled negative 9. What would make the blue thing be 0? If x equaled to 7. But that's only if it equals 0. If it just says factor like this one did, then don't go doing that next step, because it was not an equation. You would be done right here. So you have to read the directions carefully. Okay, the two for you to try. First one is just asking you to factor. The second one is asking you to factor and then solve. So pause the video now. Come back once everyone's had a chance to try and you want to see what the answers are. Okay, first one, you need to find two numbers that are going to multiply to make 26 and add up to be 15. There's not too many combinations. It turns out it's not 26 and 1, that'd be 27. It's going to be 13 and 2. Those two numbers multiply to make 26 and add up to be 15. And then you're done here. You don't go solving and say n equals negative 2, n equals negative 13, because it was not equal to 0. It wasn't equal to anything. It wasn't an equation. The second one, again, I need to say what two numbers multiply to make negative 11, add up to be 10, and then factor it. It's positive 11 and minus 1. Those are just the factors, though, and now you need to solve. If I had, red thing times blue thing equals 0, one of them has to be 0. The two answers are 1 or negative 11. Very last section we did was 8.5 graph quadratics by factoring. And I'm going to leave you to do this on your own. So this is your task, is to fill in the last section. You could go and watch the video that was recorded prior. You can look at your note packet from filling out that video and fill in an example. First you have to factor, then find the x-intercepts, then find the vertex halfway between, and then find the y-intercepting graph. And that would be the last section that we covered. And then there is one blank for you to put an extra example on. I would highly encourage you to do this on your own, because by doing it on your own, you're thinking through the process yourself, you're forcing yourself to learn it. If you're really struggling and you want an example, I have an example right here of 8.5 worked out that I will leave for you to fill in if you'd like. So if you'd like an example, there it is. Otherwise, I highly encourage you to go find one on your own and put it down so that there's a better chance you will remember it for yourself. So that is it. Thank you very much. Have a good day.